So we're going to move on to a topic that was alluded to a bit in the keynote presentation, which is the evolving demand for low-carbon commodities for consumer products and how this affects or could impact energy choices for mines. So I'm delighted to introduce Michelle Caravias. I'm sorry, Michelle, I'm not... It's okay. Okay. She is Deputy Head of Industry Research at Fitch Solutions.
Hi everyone, and excellent pronunciation, thank you. So as mentioned, I'll just move this down for the shorter people. So as mentioned, my name is Michelle Caravias, and I am Deputy Head of Industry Research at Fitch Solutions. And I'm going to be talking a little bit about the low-carbon economy and how this is presenting opportunities in terms of, for mining companies in terms of both operations and also in terms of changing client demands. So, just moving on to the... So in terms of the agenda, I'll start off with a brief introduction to Fitch Solutions, which is the company that I'm representing. Then I'll move into talking a little bit about how the low-carbon economy is impacting the mining industry. And we really see this happening in two ways. Number one, it's the kind of internal operations within mining companies. A lot of what's been discussed today around sustainability in terms of mining operations. But secondly, I'll move on to looking at how this is actually creating demand for new commodities and how we see shifting demand for existing commodities and what that means in terms of client base. So as I mentioned, a brief comment on Fitch Solutions. It's a new brand. We just launched it in July. Many of you will be more familiar with our old brand, which is BMI Research. My communications director is not in the room, so I can say that. Fitch Solutions is the non-ratings element of the Fitch Group. So I'm not going to talk about credit ratings, don't worry. I'm just going to be talking about our research around the mining and energy industries. We cover 200 different markets, very much emerging market, frontier market specialists. And we cover, in terms of industries, of particular relevance today, energy, infrastructure, renewables, mining, metals, and automotives. And I bring the last point up because a lot of the research that I'm going to present later on in the presentation is an output between our mining, automotives, and energy teams discussing quantifying the impact of batteries in electric vehicles in terms of demand. So what is that going to look like in terms of industry demand? So I'll talk a little bit about that in the second half of the presentation. So to kick off with the topic for today's presentation, mineral extraction and smelting are among the most power-intensive industries, power-intensive and environmentally destructive sectors globally. And so we see increasing social, investor, and regulatory pressure to lower emissions. I mean, we've already discussed this quite a lot today, and this is already having an impact. So what do we see as the main areas in which mining companies are have the opportunity to reduce some of that impact? Well, if we look at, first of all, the impact on integration of renewable energy into the mining sector, we've talked a lot about that so far today, and that's kind of one of the biggest areas that people go to when they think about sustainability. And we're going to talk about that in the next couple of slides. But a couple of other areas that I wanted to highlight, and which don't come up as much, but actually are also really important across the life cycle of the mine, are efforts to reduce water usage, be more sustainable in terms of reusable water, energy-efficient equipment during the development and extraction of mines, alternative fuels for transportation. This has come up a lot already around biofuels, and then technology integration to just increase efficiencies, which will overall lower energy demand. And finally, we're looking at the adjustment of asset portfolios to target low-carbon commodities, which, as I mentioned, will form the second part of the presentation. And this will allow companies to increase or decrease exposure to major pollutants like coal and emission-intense steel production and shift to those commodities that are going to support the low-carbon economy. So as we look at integrating renewable energy, we're looking at, we're looking at basically the integration of renewable energy, but also battery storage and low-carbon fuel options into the overall energy mix. So it is about solar and wind, of course, but it's also about hydropower. It's about natural gas, which is obviously much more energy efficient, and backup battery storage. Solar and wind only work where you have the climate for them to work. And so we also are looking at alternative energy solutions across the life cycle of the mine. So why do we think that this is happening now? Well, we're under no illusion that realistically cost is one of the main driving factors. The mining industry has suffered from low commodity prices over recent years and bottom line is really an important factor when looking at operational ability. So the really reduced cost in things like solar PV and wind is having a major impact on the cost economics of integrating renewables into the mining operations. And as we see on the chart, which I can just about see, the dashed blue line and the dashed red line are onshore wind and solar PV, respectively. This is the EMEA average electricity price, US dollar per megawatt hour. And what we can see is those two prices have come significantly lower in recent years and actually are competing with traditional fossil fuels in those markets. We can just about see coal is the kind of darker blue line. And so what we're seeing is actually it's becoming cost competitive to integrate renewables. So it's not just about the reputational, but it's also about it makes good economics. The other factor that we're looking at is the reliability of supply and cost consistency. This is mentioned a couple of times today, but a lot of mines are in remote locations, they're in emerging markets where you don't have consistency of grid supply, where you're exposed to potential tariff fluctuations, and by having your own source of electricity, which is off-grid or even renewables, you're ending up in a much more reliable cost environment. We have seen, especially in countries like Chile, for example, especially with remote locations in the Atacama Desert, the prices are exorbitant in terms of cost comparative compared to the rest of the world. Off-grid solutions and the integration of renewables into Chile's electric grid is really working to decrease some of those cost considerations. And power outages as well. As we mentioned, remote locations, you have to build either an extensive grid line, get electricity losses along the grid. You have that kind of potential for supply disruptions because of the infrastructure in place. And so both reliability and the sustainability are really another draw of renewables. We're also looking at regulatory pressure. This is making actually the cost of the fossil fuels more expensive. And so actually whilst renewables are getting cheaper, there's increased costs associated with traditional fossil fuels. And we're looking at things like government policy in particular, which are shifting the demand economics of the power supply. We look at India, for example, where we're seeing Coal India pledge to build 20 gigawatts of solar power to try and supply their mines. We also see carbon pricing schemes coming into place, for example, in China, and they're looking to, by 2020, to integrate carbon pricing, looking to reduce the emissions generated by mining and smelting, and these factors are all going to play a part into the costs associated with continuing to rely on fossil fuels. And we're also looking at places like Argentina and South Africa for introducing carbon trading schemes. So all of this will increasingly make renewables more attractive. And finally, we can't not mention external pressure. This is a factor. It came up earlier today. The mining sector, people are increasingly demanding more from it in terms of the environmental and the sustainability aspect of the mining sector, especially as the mining sector provides commodities, as we'll get onto later, to fuel the low-carbon economy. The clients are demanding more sustainably produced commodities. And you're also seeing a shift in investment trends. You've now got the rise of ESG investment, whereby we're seeing people looking at things like water use, energy use, to try and make decisions about whether to invest in a market, in a country or not. So these are all playing a factor into why we're seeing this shift right now. And we're seeing a lot of partnerships between technology companies and mining companies to try and pursue these kind of, millennial-friendly platforms in terms of their initiatives. So we saw Apple with Rio Tinto and Alcoa announce plans for carbon-free aluminium. And we saw BMW and Codelco announcing plans for the Responsible Copper Initiative. And all of these factors will make the clients more receptive to the products being produced. So as we look at integrating renewable energy, as I said, it's not feasible everywhere. We have to look at where it makes a lot of sense. The example we had earlier was from Namibia. Namibia has one of the highest irradiation levels in the world. It makes a very much attractive sense to build a solar panel plant there. So when we look at where do we think this is going to be the biggest trend, we use our renewables risk-reward index. What is that? Well, effectively, it measures the rewards of investing in renewables in certain markets. So this addresses the policy concerns around where policy is attractive for investment in renewable energy. And it also looks at things like our forecasts for growth in terms of renewable capacity and demand for energy. And we offset that with risks. So where are we looking at competitive landscape, potential for regulatory shifts that could impact the attractiveness of these markets, and putting all that together, we come up with a number. The darker the color, the more attractive the market, just to kind of explain what's going on the chart. And so when we cross-reference that with the largest mining industries globally, it allows us to pick out a few markets that we think are going to be leaders in terms of integration, the opportunity to integrate renewables into mining operations. And we'd highlight here Chile. I mean, it's already there in terms of a lot of the mining operations in the Atacama region. We'd also look at China, Australia. Again, the high cost of electricity there makes renewable energy very attractive. And India, in terms of increasing policies which are making renewable energy much more cost effective. So as we move on to away from renewable energy specifically, when we look at where else mining companies and the mining industry can increase efficiency and increase sustainability credentials, and we look across the entire life cycle of a mine's operation, in addition to the indirect emissions aspect, which of course is a factor as well. So when we look at things like sustainable water usage and reduced water usage, we look at processing and extraction. And here, which is both very water-intensive parts of the process, and here we're looking at new technologies around dry processing, which can allow reduced water usage, or desalination. And in some markets, actually, desalination units are part of the requirement in terms of setting up your operations. Chile, again, a good example. And this allows you to use reusable water, renewable water resources. Another area is the use of the equipment in the extraction process, more sustainable and energy efficient equipment, so reducing your overall energy consumption. Another aspect that I wanted to touch on was the reuse of sustainable materials and the development of the mine. It was mentioned earlier around, do you still need a road if you are building, if you don't need as much diesel delivered to the mine? Concrete is one of the highest sources of carbon emissions globally. So if you reduce the need to build roads, then you're reducing your indirect emissions through that route as well. Related, transportation, major use of energy. You can't use, solar-powered mining trucks, for example. So where do you shift the energy demand there? And so we're looking at electric vehicles, very early stages, but electric vehicles, electric automated vehicles even, and we're also looking at alternative fuel vehicles as well, so the integration of those into the life cycle of the mine. And finally, as I said, just tech integration across the entire mine life cycle. Another part of what we look at quite a lot is the tech impact on industries. And we're seeing major improvements in terms of technology integration around Internet of Things. And this is allowing increased efficiencies in operation, reduced downtime, reduced lag times, which can really reduce energy consumption in the first place. So I'm going to move on to the second part of the presentation now, which is looking at the shifting demand for commodities as a result of the low carbon economy, and so how miners can adjust their asset portfolios and which metals and minerals we think are going to be benefiting from rising demand as a result of the low carbon economy. And really, this is two areas. It's batteries for electric vehicles in particular. Obviously, there's batteries for storage, but really electric vehicles is going to be the driving force. And then secondly, the power mix. And of course, you can't not mention coal when we're looking at the power mix. So as we look at electric vehicles and the batteries demand for, or metals demand from batteries from electric vehicles, first of all, we have to figure out how many electric vehicles are there going to be in the market. So we produce forecasts, 10-year forecasts for electric vehicle sales, for fleet, percentage of total fleet, across 53 different markets. And the chart on the slide illustrates our forecasts for electric vehicles across 3 major markets, China in the pink, Europe in the light blue, US in the darker blue, and those 3 markets actually account for 90% of the global electric vehicle fleet, and then the little bit at the top is the rest of the world as well. And so what we've seen in terms of our forecast is that by 2027, we estimate almost 5 million electric vehicle sales per year. This is still very small compared to total vehicle sales globally, of course, but it represents a significant ramp up in demand for batteries, significant increase in the battery storage and batteries that will be needed globally. If we look at where this is coming from, well, China. The pink is all China. China is the largest electric vehicles market in the world and will remain the largest electric vehicles market in the world. We also see significant growth in Europe, where we expect favourable policy, government subsidies, and just consumer preferences to really drive demand for European electric vehicles. And I should note, in China, we expect 13.4 million electric vehicles by 2027. In Europe, it's about 7 million by 2027. The US is trailing a little bit behind the rest of the world because of inconsistent policies both at a state and federal level. We expect just 2.7 million electric vehicles from the US in 2027. Notable fact, California will really be the driving force behind this. In 2017, accounted for 50% of all electric vehicle sales in the US. So it's really all about California in the US. So as we look at how this translates into then battery demand and what minerals we think are going to outperform, you have to then say, okay, well, we know there's going to be electric vehicles production, we know we need batteries, but what are the battery chemistries that are going to be dictating that demand? Because obviously that will really impact which minerals we're going to see outperforming over the next 10, 20, 30 years. So we looked at our electric vehicles, we looked at which battery facilities were being developed, and we came to the conclusion that 3 different battery types would be the most prominent. Probably no great surprises in the 3 that we've identified here, but hopefully there'll be some more surprises in the metals that we'll identify as a result of this. But the 3 battery types that we identify are NMC, so nickel, manganese, and cobalt, NCA, which is nickel, cobalt, and aluminium, and LFP, lithium, iron, and phosphate. So those are the 3 types that we're really highlighting. Why are we highlighting these 3 types? Well, China is the largest market for electric vehicles and the largest manufacturer of batteries globally. So basically what happens in China impacts what's happening in the market globally. Chinese brands currently favor the LFP battery type. This is low cost and reliability. We'll get onto this a bit more in a minute. But actually they are moving towards the NMC battery type because recently regulations were put in place to make that battery type more attractive to producers. The other factor in the US looking at NCA, is Tesla. Tesla uses the NCA battery. This is therefore the most popular battery type in the US. As Tesla shifts some of its production of batteries to China, we expect NCA actually to be more popular in China as well. So both those are going to be growing in China. And third, if we look at Europe, Europe currently has more limited battery manufacturing and currently is split between NMC and LMO, lithium, manganese, and oxide. But actually we're going to expect that Europe will also shift towards the NMC battery type as German producers look to try and set up domestic manufacturing facilities and are preferring the NMC battery type. So what does this all mean for metals demand? What is the kind of outcome? So the chart on the slide here is metals demand. It should be thousands of tons, not just tons. The metals demand from electric vehicle battery manufacturing overall. And what we see here, the light blue line, is nickel, just outperforming every other metal type in terms of cumulative demand in terms of tonnage. Why is this? Why is nickel the outperforming metal for us in terms of batteries? Well, we're looking at a couple of different factors. Number one, the NMC cathode we expect will be the battery of choice. Why is this? Well, high energy density, thermal stability, and low cost combined makes it the most attractive battery choice. We expect it to account for 63% of all batteries, electric vehicle batteries, by 2027, compared to just 28% now. So massive ramp up in NMC batteries. Why is this? Well, China, as I mentioned, is shifting from LFP to NMC owing to regulatory changes. And so by 2027, we expect over 50% of all cathodes in China to be NMC cathodes. So that's going to really drive demand for nickel, one of the main component parts of this battery. And actually, nickel is likely to become a more important part of this battery as producers look to move away from the cobalt part of this battery. So currently, NMC is 6 parts nickel, 2 parts manganese, and 2 parts cobalt. This is 622 battery. But actually, because of a lot of issues around cobalt mining in terms of both the price volatility and price spikes and the sustainability and ethical concerns around cobalt mining, currently, a lot of manufacturers of batteries and electric vehicle manufacturers are demanding a move away from cobalt. And so what we're seeing is the rise of the NMC 811 battery, which is 8 parts nickel, 1 part cobalt, 1 part manganese. And so we believe that that's going to further support demand for nickel over the 10-year, 20-year horizon. And actually by 2027, we expect the NMC 811 batteries will account for 80% of all NMC batteries. So a real shift away from cobalt unless we see a major change in the credentials around cobalt mining. So what does this mean for cobalt? Well, often cited as one of the kind of big winners from the battery revolution, we're seeing the demand upside is actually limited for cobalt. So I've produced the same chart here, taken out the nickel line so we can zoom in on the rest of the minerals that we're looking at. And cobalt is the blue line. It's the second from lowest, just if you can't see which color that is. So it's actually going to underperform in terms of our forecasts for demand. It's going to underperform lithium, iron, and manganese. So as I mentioned, we are seeing a shift away from the NMC 622 to the 811 style of cathode, which is really going to reduce the demand for cobalt. If we're looking at some of the other metals that we think are going to benefit, lithium, it's used in all of the battery cathodes, so it's obviously going to have significant demand growth. That is the reddish, pinkish line, the top one, basically. And manganese, we kind of highlight as well because of the same elements in terms of the battery usage for manganese. So moving on to a more surprise winner from the batteries trend is iron. This is, especially over the next 10 years, we think iron demand is going to be supported by electric vehicles, batteries production. Iron is a key ingredient or key aspect of the LFP cathodes, and they do remain very popular in China. So I mentioned that China is shifting from LFP to NMC, but we do expect it to remain a prominent part of China's battery manufacturing mix, and will account for 19% of all sales in 2027. And if you saw the size of the Chinese market, that's still a significant amount of batteries with the LFP chemistry. The chart on the slide shows China's direct demands for electric vehicle batteries, electric vehicle metals, sorry. The pink bit is iron. So as you can see, really over the next 5 years, we expect strong growth in LFP, in iron. It's going to reduce a little bit at the back end of our 5 years, but still not going anywhere anytime soon. For reference, nickel is the grey bit, if you can't see it. So that was kind of reinforcing that point about nickel. So iron demand cumulatively will be second highest after nickel over our 10-year outlook. So really significant boost there. And actually this is coming at a time when iron ore, we're pretty bearish about iron ore overall. Bearish about iron ore prices, and you can just about make out the chart on the left-hand side as our price forecasts for nickel versus iron ore. Iron ore is grey. Over the next 10 years, you can see stagnating prices. And so this is going to provide some support to the iron ore industry, because otherwise we're seeing a real stagnation in demand as China reduces its current economic setup from a more capex-driven economy to a more consumption-led economy, and reduces steel consumption as a result. So some upside to iron ore demand there and iron ore prices. So I'm just going to finish off with a brief mention on the power mix, shifting gears slightly. So when we look at the power mix and kind of the demand for different mining-related commodities, obviously coal is the big picture here. And we do expect that coal will lose its dominance over the next 30, 40 years. Over the next 10 years, we expect coal generation globally to go from 38% of the total to 34% of the total. So it is declining, but it's still the largest piece of the puzzle in terms of power generation globally in 2027. So it's not really going anywhere. What it is doing is shifting to very much an Asian story. So we expect that coal power will account for 51% of Asian power generation in 2027. Why is this happening? Well, it's very attractive price-wise, and its very widespread availability means that it's really a popular source for markets that are looking to really ramp up their power supply. And we would highlight markets like China, India, Indonesia, Vietnam, Philippines, Pakistan as markets where we're really seeing growth in demand for coal for power generation. Another factor is the Belt and Road Initiative. China is looking to really drive exports of coal power generation technology. And if you look along the Belt and Road and you look at the power plants associated with the Belt and Road, over 50% of them are coal-fired power plants, equal to about 80 coal-fired power plants that China's developing outside of China through the Belt and Road. So that's going to support, again, coal's presence in the power mix. However, that being said, over the longer term, 30, 40-year horizon, we do expect coal to lose its dominance. It's the improving cost of renewables, going back to that point at the beginning. Renewables are becoming increasingly cost competitive, so that cost factor is mitigating. We're also seeing driving government regulations, the Paris agreements, also all putting coal under the spotlight. And also financing coal-fired power plants is pretty hard these days in terms of getting the financing from development institutions or other aspects because of the credentials associated with it. So this will drive adoption of cleaner alternatives. And if I showed this same chart but I showed capacity rather than generation, renewables would be a much larger portion of the pie. Obviously, due to their intermittent nature, it doesn't form as much of the generation mix. And so this actually will come back to the batteries, drive more demand for batteries, more demand for energy storage, and we would highlight markets such as China, India, Japan, Australia, and Taiwan as key energy storage markets for the future based on the amount of renewables we expect to see added to the grid. So I'm going to finish there. Thank you very much for your time today, and thank you to Energy and Mines for having me to speak.